I'm going to break this chapter up into several parts this time instead of just two, see if that is more easily digestible. You've read about the macronutrients that provide calories, and the last macronutrient is water. And water is really the most essential nutrient. It is the one that if we don't have it within days that we die. And the interesting component in terms of sport nutrition is that you can have small perturbations or small decrease in body water, and it can result in a decrease in performance, which is what you're here to learn about. The body is between 55 and maybe even 70% body water. It just depends on what the individual's percent body fat is, to be honest, because the greater the fat content, the lower the body water content will be, because fat repels water and muscle is primarily has a large percentage of water. The water content is intracellular or extracellular, and you can see that the extracellular component is the plasma and the interstitial. That is the component of the fluid that we get in our blood and also in our lymph. So that's our extracellular, or ECF. The intracellular is about 2/3 of our body water, and that's what's inside the cells. Water has many functions in our body, and with exercise, the component that I look at the components that are really important would be to maintain body temperature for cooling. That's going to be associated with the ability to remove heat from the core through perspiration. It's involved in chemical reactions, and when we think back about metabolism, the end result of metabolism is carbon dioxide and water, and so that's metabolic water. It's involved in pH, and we'll show you that in another slide. It helps to maintain structure of the cell because of the interstitial component of water. It is important for maintaining our ability to adapt to temperature changes and also pH. So water has a myriad of functions. We get majority of our water from drinking ingested fluids, and that includes where we get our water from the tap or for a bottle, although as you can see, there's really no benefit of having bottled water over tap water, if you have good tap water, of course. The caffeinated water or caffeinated drinks can count, although they do have a diuretic component. It's not 100% caffeine beverage in, 100% caffeinated beverage out, so it can count. We have milk, sports drinks, juices, and other beverages. We also get a fair amount of fluid or water from our ingested foods. Now, you can say less than 20% is not a lot, but if you have soup, fruits, vegetables, there is an example, say watermelon. Watermelon has a tremendous amount of water inside of it. So eating whole foods also contributes to our source of water, and the remainder is formed during metabolism, which is a very small amount, but it does count. Wanted to remind you about the metabolic contribution of the metabolic water, and this is just a figure from chapter 2, where you have our macronutrients that are metabolized either aerobically or anaerobically, and we have our end result of our metabolism being water and carbon dioxide and hydrogen ion and lactate through the aerobic and anaerobic system. And so here you'll see in the bloodstream we have a contribution of water just from our metabolism, and that's our metabolic water. It's not a large percent, but it does contribute. And as a person exercises in higher intensity, that metabolic water will increase in amount or contribution. The component that is related to the ability for how water is related to pH is that we have our, at rest at the top, we have water and carbon dioxide that came from metabolism, and these two can join and become carbonic acid and ultimately become sodium bicarb. And sodium bicarbonate is actually a buffer. It's a really, it's basically it's basically like baking soda, right? It's got this real ability to grab that hydrogen ion and become a buffer. During exercise, this sodium bicarbonate will then be available to make carbonic acid, and it'll grab onto that hydrogen ion and keep the pH in a normal value. So this water and carbon dioxide joining together with that sodium helps with grabbing onto that hydrogen ion and keeping the acid base or pH correct in our body. We lose water through a number of ways, and you can see here are our water sources with food, drink, and the metabolic component coming in. And we have our main portion, as you can see, is through the urine, through the kidneys. So you'll see that almost, well, there was a majority of it, quite a large amount of it is coming through the production of urine. Defecation, which is the very bottom of that water output value, is a very small amount, but it does contribute. And during exercise, you'll see that skin has a very big range of 450 to 1900, and this is to identify the large potential for losing body water through the skin via sweat during exercise and also during a hot environment. We have insensible perspiration, which is contributing to that small amount that we're losing all the time through our skin and also through our lungs. We see it in the cold when we breathe out and the air is really dry, and you see that water puff when you breathe out in the cold weather.